Hi all. So this is the solution for the quiz 2. We have a total of 8 questions and 2 parts. So the question 1 requires us to give the appropriate structures of compounds B to E which are major products in the given reaction scheme. So the reaction 1 is the formation of the amide from an amine and acetic anhydride. So you should form the amide functional group here. And the reaction 2 is the electrophilic aromatic substitution. So we have two positions, right? So this is the remind from the lab 5. So the substitution should be occur at the metal position to the carbonyl group. Or you can see the amine which has the lone pair on the nitrogen atom, which is the electron donating group. So the nitro group will be introduced at the ortho position to this amide group. So the major product C should be like this. D is the product obtained from the Sandmeyer type reaction from lab 9. So we form the diazonium from this amine, and this diazonium will be replaced by iodine at the second step. And the reaction 4 is the Wittig reaction. So if you know the mechanism, you can see that this carbonyl carbon we remove this oxygen and replaced by the nucleophilic carbon attached to the phosphorus here. We don't care about the stereochemistry here, so you can give the 0 E isomer. It's okay to me. So for the points for this question, if you have one correct structure, you will have 5 points. If you are missing the carbon atoms, hydrogen atoms, you can have the line from 1 to 2 minus point. For the product C, if you give the other regional isomer, which is the ortho position to the carbonyl, you will have only 2 points, which is the partial for this part. For the question 2, requires you to give the key resonance structure to explain why we often compound C as the major product while the other is the minor product. So when you try the resonance structure, you will see that this compound, if you form the nitro group at the ortho position to the amide, you will place the carbon cation on this carbon, right? And this is stabilized by the lone pair of the nitrogen atom via the resonance structure. So I will draw the resonance structure when we use compound B and attacked by the nitro neomion, which is the electrophile in reaction 2. I keep this double bond intact. And if you move this pi bond to attack the nitronium ion, you will place a positive charge carbocation here, right? And we use the lone pair on the nitrogen to draw the second resonance structure, which is stabilized form of this intermediate. And you also need to give some words like carbocation is stabilized by adjacent electron donating group. So in this case, this is the NH with a lone pair on the nitrogen atom. But if you introduce the nitro group at the other position, for example, ortho position to the carbonyl group, what will happen? So now, instead of forming from this position, I will form the product that has the nitro group attached to this carbon. Now you have a carbon cation next to the electron withdrawing group. So this is the destabilized intermediate. So this will give you the minor product because this intermediate has the carbocation is destabilized by the adjacent electron withdrawing group. So in this case, it's the carbonyl group. So carbocation is destabilized by adjacent electron withdrawing group. In this case, it's the carbonyl group. So for the points for this question, we have one resonance structure has 2 points. The second resonance structure, which is the stabilized form of this. The arrow for the resonance structure works to explain. We have the destabilized intermediate and explanation. So the total point for question 2 is 12. Q1 is 20. For the question 3, we circle all reactions that involve the nucleophilic addition to the carbonyl group in the mechanism. So we have only reaction 1 and 4. So reaction 1, we have the nucleophilic attack of anhydride, carbonyl group in the anhydride by the amine. While the last reaction, we have the nucleophilic attack of this carbonyl group by the nucleic carbon or the elite. So for each correct choice, you have 5 points. But you will lose 2 points if you choose at least one of the other. For example, if you choose reaction 1 and 4, but you also choose reaction 2, so you lose 2 points, and your points for the question 3 here is 8. So now we have 10 for the question 3. And for the question 4, reaction similar to reaction 4 was done in lab 7 using pipette filtration. So I'm looking for the keywords for the question 4, like the aim of this technique is to help you remove the solid byproduct. In this case, this is the triphenylphosphine oxide. So to help you remove triphenylphosphine oxide, which is the solid byproduct. So this is the keyword. And we have 8 points for this question. I will give you only 4 points to 6 points if you don't clearly show me the solid byproduct. Some people said just enhance the purity. It is not enough, right? Because there are many other techniques that can also enhance the purity, like recrystallization. So you need to give me keywords that help other people when they read your answer, and they can, okay, think about the difference of the pipette filtration compared to the other techniques. So the total points for this question is 50. Okay, now we move to the part 2 about the aldol condensation reaction. So I give you 2 boxes, right? One for the aldehyde and one for the ketone starter material. So you need to disconnect the bond. So you can see that this is the alpha beta unsaturated carbonyl compound. So if you can see, this is the chemistry of the alpha carbon, like the enolate. So the alpha position should be comes from the enolate, and the beta carbon should be comes from the electrophilic carbon, right? In this case, this should be the aldehyde. So the correct aldehyde F is this. Make sure that you keep all the other part of the molecule. So this carbon is the aldehyde, right? This should be like this. And the right moiety of the product comes from the ketone. So we have the ketone with 1, 2, 3, 4, 5 carbon, and the C3 we have the carbonyl group. For each correct structure, you have 5 points. So the total points for question 5 is 10. For the question 6, circle all the rows of sodium hydroxide in this reaction. So sodium hydroxide is a base. And if you look at the mechanism for the aldol condensation reaction, you can see that hydroxide anion acts as a catalyst, right? Because it deprotonates the alpha hydrogen of the ketone to form the enolate, which is the nucleophile. And at the last step, it will promote the elimination of the beta hydroxy group to form the conjugate enol. So the hydroxide anion is recovered at the last step, so it is act as a catalyst. So if you choose for each correct choice, you have 5 points. But if you choose each of the other, you will lose 2 points, like it cannot be the solvent. The solvent in this reaction is the ethanol here. So if you choose base catalyst, but you also choose the solvent, you will lose 2 points, and now you have 8 points if you have that choice, right? So now we have the 10 points for this question. For the question 7, if you carefully practice the percent yield calculation, you can do this easily. So now When you read the procedure, you can see that the mole ratio of F to G is 1 to 2, and they give you the yield 23%. So for the question 7, 500 milligram of H, this is the amount that you should prepare, right? So when you want to prepare 500 milligram of H, so this value is the actual yield. So this should be the actual yield. When you have the actual yield and you have the percent yield, you can calculate the theoretical yield, right? So you can see that the percent yield is calculated by we divide the actual yield by the theoretical yield. So now we want to find the theoretical yield. So from that theoretical yield, you can calculate the amount of each reactant in the reaction. So now we use the 500 milligram, which is the 0.5 gram of H. And we divide by the percent yield, it is 23%, right? And now we convert the grams to mole by using the molecular weight of compound H. So this is the right calculation. So now gram will be removed and you only have the mole of H here, right? And if you use the calculator, you can have the value of mole of H is 0.0122. So from these results, which is the theoretical yield of the product, you can calculate the required mole of each reactant. So now we calculate the amount of compound F first. So the ratio of F to G is 1 to 2. And in the reaction, you can see that the phone balance chemical reaction is also 1, 1, and give 1 product in mole, right? So now from the mole of H, we can see that 1 mole, for each 1 mole of aldehyde F, we will produce 1 mole of compound H. So 1 mole of compound H is produced from 1 mole of compound F. And now we convert the mole to gram using the molecular weight. So because we want to remove the mole, so we should place the mole at the bottom. And then the molecular weight of compound F is like 1 mole of F has the 10.11 gram. And because that is the liquid with the density value here, so you need to convert gram to millimeter using the density value. And because we want to remove gram, so we should put the gram at the bottom. So 1.107 gram H for 1 milliliter of A compound F. Right? So now you can remove mole F H Oh, sorry, this is the mole of compound F. And gram of F. So we keep the volume of F here. And the result is 1.21. We use the mole of H to calculate the mole of G, but be careful. The ratio in mole for F to G is 1 to 2. So it means that to produce 1 mole of compound H, you need 2 mole of ketone G. So for 1 mole of product H, you need 2 mole of ketone G. And we remove the mole of G by using the molecular weight of G. And then the density of G. From now, we reduce the mole of product H, mole of G, gram of G, and now we only keep a millimeter of G. So the result is 2.58 millimeter of G. For the palm credit for this question, you have 6 boxes, right? Each correct boxes will have 4 points. The maximum point for this question is 24. I can say most of you cannot give the right result for this question. So if you have the wrong result, it means that you lose at least 12 points. But even when you have the wrong result, but the calculation in the box of you are right, you will also have the full points for these 2 boxes. But because you do the wrong calculation at the first box, so most of you just have like maximum 2 points. So even when you have the wrong, incorrect results, you have at least like 10 to 12 points for this question. For the question 8, it is very easy. So the key here is we notice that the product compound H is the colorless oil. Because it is an oil, so we cannot use vacuum filtration, we cannot use melting point, determination, or recrystallization, because these 3 techniques are used for the solid compound, right? Vacuum filtration, this means that your product should be the solid, so it will be like placed in the filter virginal funnel, right? The melting point also apply for the solid compound and the recrystallization. Recrystallization will help you enhance the purity of the solid product. But because your product H here is the colorless oil, so we can only use the TLC analysis and the IR spectroscopy to analyze the compound H. So each correct choice have 3 points. Maximum point is 6. If you choose at least one of the other choice, you will lose 2 points. Okay, so the maximum total points for the part 2 is 50. Now this is a bonus point. Okay, so you can rewrite the structure. For the region about 6 to 7 ppm, which is the region for the CsB2H, the proton attached to the alkene, which is the double bond here, right? So we don't have any quartet in this region. How many singlet for this? We have one proton here. Alkene, proton attached to this carbon, and we don't have any neighboring proton adjacent to this carbon, so we have one singlet here. For the doublet, we have these two protons. You can see that this proton also attached to the alkene, right? And we have, for each proton, we have one neighboring proton. So this proton will give the doublet, and this proton will also give a doublet. So we have two doublets, and we don't have any triplet. For the region 2 to 3 ppm, it means that we have the proton attached to the maybe the allylic carbon or the alpha carbon next to the carbonyl group. So we have this proton, right? So this proton and this proton, we don't have any neighboring carbon next to it. So we have two singlets. For this proton, which is the alpha, attach the alpha carbon next to the carbonyl, it will show up in the region from 2 to 3. But it has 3 neighboring protons. So this proton will give the signal, which is the quartet, right? So we have one quartet, but we don't have any duplet or singlet or triplet. For the region at 1 ppm, you only have this methyl group, right? So we have 2 neighboring protons. So these 3 protons will be split into a triplet. So we are only one triplet at the region about 1 ppm. And 0 singlet, doublet, or quartet at the region about 1. So if you have one correct number in this position, you will have 1 point. But I can see somebody, they don't write any number, so I cannot give them the bonus point. Even when it is a 0, you must write 0 to have the bonus point. Okay, so we finished.